Okay, Unit 1, first day of notes, function notes. A relation shows the relationship between input and output. Input is the x, output is the y. A function is a relation which only has one output for every given input. That means one unique x with one unique y. The domain is a set of all x values, the inputs. Range is the set of all y values, which is the outputs. Discrete is a graph that has scattered points that may not show direction or a trend. And continuous is a graph representing a smooth curve that is not interrupted. All the points are connected. Okay, now we're going to tell if a relation is a function, and we're going to look at two different things right now. We're going to look at a set of points and a graph. So on a set of points, we want to see that the x values do not repeat. So I've got this first number 1, I've got a -1, a 5, an 8, a 7, and a 5. I have matching x's at 5 and different outputs or y's, so no, this is not a function because the x repeats. The next one, I have 0, 1, 2, 3. None of the x's repeating, so yes, it is a function. Okay, so now on graphs, remember we determine if it's a function by using the vertical line test. I can draw a vertical line through this relation, and I can see it only touches the relation in one spot. So yes, this is a function. This number 4, when I draw a line, it is touching this relation in 2 spots. So no, not a function. Okay, now on to domain and range. Remember, domain is how far left, how far right. Range is how far down, how far up. A couple other things, remember that when you're in an open circle in an equality world, there's no line underneath. And in interval notation, it's a parentheses. And then a closed circle has the line underneath the inequality, and we use the squared off brackets. So this first relation that we're looking at, and we can look at that and say, yes, it's a function because it passes that vertical line test. So the domain is how far left, how far right. The left side of the graph is an arrow, so we designate that with negative infinity because it's on the negative side or the negative range of x's. And then on the right-hand side, it is an arrow, so that is just infinity. And a lot of us say positive infinity. Infinities will have parentheses because it's not a designated point on the graph, so we use it like an open circle. Our range is how far down to how far up, so I start at the bottom of the graph. The first point I come to is there at the origin, so the y-coordinate is 0, and the top of that graph is arrows, so that's infinity. That 0 is a point on the graph, so I use the squared off brackets and then a parentheses around the infinity. Okay, the next one is called a step function, and if you look at it, you have to just kind of pay attention. It's a closed circle, and then it goes to the open and up, and it's closed and closed and closed, and that is continuous. There are no breaks in that graph with my domain, so my domain goes from 0 to 5, and at 0 it's a closed circle, so I use the bracket, and at 5 it's an open circle, so I use the parentheses. Now at the bottom, the range goes from bottom to top, but there are gaps, and they are just discrete points on the graph. And we are looking at the farthest or the lowest point is at 0. And we're going to use set notation, which is the fancy brackets. Then I have a distinct point at 1, at 2, at 3, at 4, and 5. The point at 6, 5 is the highest it goes. Okay, now this third one, At this point down here is at -1, -1. This point up here is at 1, 5. So now my domain is a set of x's, so the x goes from -1 to 1, because this is continuous. And down at -1, it's an open circle, and up at the +1, it is a bracket because it's closed. The range is bottom to top, and so the lowest point is at -1, the highest point is at 5, and down there at -1, it is a open circle, and at the 5, it's a closed circle. Then this last one is a continuous graph. This point is at 0, 0, which is the origin. So the farthest left I go is 0. The farthest right is the arrow, so that's infinity. Parentheses around the infinity, bracket around the 0. The lowest point on the graph is 0. The highest point is the arrow, which is infinity. Parentheses around the infinity, and a bracket around the 0. Okay, now to a little bit of our function notation. F of x, remember, is the y. F of x is used when it's a function. We use y when it's a relation. I have a function which happens to be a linear, which is 2/3 x plus 6. And it tells me to find the indicated values. So f at 3 is telling me x equals 3. And I am to plug in that value and find its y, or output. So it's 2/3 times 3 plus 6, and then that is 2 plus 6, which is 8. Okay, the next one is -7, so 2/3 times -7 plus 6, and those of you not good at fractions, top times top, bottom times bottom, -14 over 3. I got to get a common denominator of 3, so that would be 18/3. So -14 plus 18, this is at 4/3 at 7. And now I'm going to plug in a -2. So, this one says f of x equals -2. That means the y equals -2. So I'm going to put in place of the y -2. And now I have to solve for x. So now I'm going to subtract that 6, which is -8. Multiply both sides by the reciprocal, which is 3 over 2. So x is now alone, and that is -12. So that is x is -12. A way to write that in function notation would be f at -12 equals -2. Just like we did these statements up here. Okay, so now I have f of x equals 8/3. So that is also 8/3 is equal to 2/3 x plus 6. I am going to subtract 6, and now 6 with a denominator of 3 would be 18/3. So I'm going to subtract 18/3 on this side and get -10/3 is equal to 2/3 x. Multiply both sides by the reciprocal. So x is now going to equal -5. Okay, so now we're doing the same thing, but this time we're looking at a graph. So notice that I'm using G's and F's, and F and G is written here. So A tells me to go to the G function when x is 3. So here x is 3. And where is the y? It's right there. So this is equal to 1. Now this one tells me to go when f is +1, it's up here at 4. And when f is -2, it's down here at -1. And now this one tells me to when is g, the y equal 3, so I count up to 3, and that's when it's 3, so it's down here at 4, so x equals 4. Okay, some more. It says evaluate and find f at -2 minus g at 2. So I'm going to take this f function and in place of x, plug in -2. So I'm going to put this function here and do -2 squared minus 1 minus, this says put a 2 in place on the g function, so that's 2 plus 1. Now I'm just going to do the math. So -2 squared is 4. 4 minus 1 is 3. 2 plus 1 is 3. 3 minus 3 is 0. And there is my solution. This one says in the function I am going to place x minus 3 in place of all the x's. So this is equal to 1 minus 2 times x minus 3 plus 3 times x minus 3 squared. So 1, remember, we are distributing a -2 to everything in that parentheses, so that's -2x, positive 6, plus 3, and now I've got to square this binomial. Well, I'm teaching this in class, but we're going to do something called square double square. Square means square the first term. Double it means if I multiply that together, I get 3x. Double it minus 6x, and then square the last. So -3 times -3 is positive 9. Square double square. And now I need to distribute that positive 3 to everything here. So 1 minus 2x plus 6 minus 3x squared minus 18x plus 9. Now I've got to put this all in order. So we do this in order of power, descending powers alphabetically. So the highest power is at -3x squared. Then I'm going to look at my x values, which is -2x and -18x. So that's going to give me -20x. And then I've got a 1 and a 6, which is 7. 7 plus 9 is 16. And there is my final answer. Okay, so we've got a little bit more of the same thing. We're looking at a different graph. So when f is 0, here's 0. My function down here is at -2 at 0. Then when f is 2, here's x at 2. And there are 2 spaces that I'm looking at. I'm not using that open circle because there's nothing there. It's an open circle, it means it's not being used. So when the function is at 2, the y value is at 1. The domain is how far left and how far right, and when I look from left to right, there are no open spots. So my domain is going to be all the way at the far left at -3, and it is a closed circle. And at the far right, it stops at 5, which is a point, which is a closed circle. My range is from bottom to top, and there it has no openings. So the very bottom is down there at -4, and it's a point on the graph, so it's a bracket. The top is at +4, it's a closed point, so it's on so it's a bracket. Now when I go determine if it's a function, right here is the only place I've got to really look, but because on the check mark it's an open circle and on the little segment it's a closed, that value at 2 is only being used one time, so it holds the definition of a function, so we would say yes. Okay, now we're going to practice a little graphing with a little piecewise, kind of start and stop. 2x plus 5, and it's only going to begin and go to the left of -1. So my -1 is right here. So now when I go to graph this, this says to start off at the +5, 1, 2, 3, 4, 5. And it has a positive slope of 2, so down 2 over 1, it's an open circle there. Down 2 over 1, down 2 over 1. So that is that piece of the function. And it goes on and on and on in that direction. So now, and so the blue, let me do this, sorry. So that was in blue. Now, f of x equals -2. That is a horizontal line going through -2. And it tells me I'm going to start at x value of -1. And that is going to be a closed circle. So closed circle here. And now I go to 2 and open circle it. And then the last piece is a quadratic, x squared minus 3, and that goes from 2 to 3. So x squared minus 3 would be graphed at -3 down here. Quadratic is over 1 up 1, over 2 up 4, and that's at 2, so that's a closed circle there. And then I go back to the vertex and go over 3 up 9. And it says closed circle. And this is like a curvy kind of quadratic. And that is a piecewise function. So now, with the graph, I can answer these questions. I'm going to talk about using both the graph and the restrictions. So the function at 2. So when my function is at 2, which is, let me use another color, which is right here, that answer would be over here at +1 because that's a closed circle, open circle again. Also at 2, this is an open circle here, so I would use this function, which would be 2 squared minus 3, which is 4 minus 3, which is 1. So that's algebraically how you would do it. Okay, so the next point is f equals 3. So 1, 2, 3, that's there. And that's up here at the top. So that is at 6. And again, 3 is in this range. So 3 squared minus 3 is 9 minus 3, which is 6. So algebraically, I can still get there. So that's what I wanted to point out. We can still get there algebraically if we don't have the graph. Okay. And now the next one is when f of x equals 1, or -1. So I come down here at the -1, and it's over here on that blue graph. And at -1, that's at 3, or -3, sorry, x equals -3. And then my domain is, I look and there's no breakage in the graph. So my domain is going to be from -infinity, because that's the far left is the arrow, all the way to the 3 on that green piece, and that's a point on the graph. My range is how far down to how far up. So again, at the bottom of the graph is an arrow, so it's -infinity, up to that top green piece, which is at 6, and it's a point on the graph. Hopefully that's enough to help you answer the rest of the questions.